employees' yearly dental expense is uniform on 200 to 1200. The primary dental plan reimburses an employee for up to 400 of dental expense in the year, while a supplemental plan pays up to 500 of any remaining dental expense. By remaining, it means remaining after the first plan has paid 400. So let Y represent the yearly benefit paid by the supplemental plan. So we're talking about the supplemental plan, this one, the one that pays in excess of 400, anything in excess of 400, up to 500. So first of all, the expense is uniform on 200 to 400 to 1200. So f of x is equal to 1 over 1200 minus 200, where x is the expense, yearly expense. So that's equal to 0.001, and that's as x goes from 200 to 1200. And y is what we are after the variance of y. So y pays up to 500 of any remaining dental expense after the first plan has paid 400. So up to 400, Y doesn't kick in because Y only pays things in excess of 400. Up to 400, the primary plan takes care of it. So therefore, Y is 0 as long as X is less than or equal to 400. X is the expense. But once X gets past 400, then Y takes care of the excess, but not limitlessly. The maximum it takes care of is 500. So which means, the maximum benefit that Y provides is 500. So which means that if the expense is 400 to 900, and the reason why we stop at 900 is that it pays in excess of 400. So when you do, so if the total expense is 900, then 400 of that is being taken care of by the primary insurance, and then 500 is left. And beyond that, it doesn't cover. So that's why this one, the x minus 400 expression applies only as long as x is between 400 to 900, and once x gets 900, you could also include the equality here, doesn't matter. But once x gets past 900, so let's say if it's 901, then 901 minus 400 is 501, and this plan is not going to pay 501 because it just stops at 500. So anything after 900, the maximum benefit you get by this secondary insurance is 500. All right. So we are after variance of y, so we will need the expected value of y and expected value of y squared. So we know expected value of y is y, the integral of y against the PDF. And normally it's negative infinity to infinity, but here, and remember the reason why we integrate y against f of x instead of f of y is that eventually we're going to change this y in terms of x. So nothing is gained as long as x is less than or equal to 400 in this integral, because the y is 0, and so this one would be 0. But when x is between 400 to 900, then y is x minus 400. So y is x minus 400 between x 400 and 900, and the f of x is always 0.001. And then when x gets past 900, then the y is 500. But we don't go from 900 up to infinity, but we go from 900 up to 1200, because after that, the f of x starts becoming 0. F of x is this 0.001 only up to 1200. After that, it's 0. So that's why we stop at 1200. So in this part, y is 500 and f of x is 0.001. And now integration. Now the easy way to integrate this kind of integral when one of these limits matches with this number that is being subtracted is, so first we pull out the 0.001 and then just treat this as a whole thing. You can think of u equals x minus 400. So the integration would be x minus 400 whole squared by 2. And this one, you multiply these two, you get 0.5, and then the integral of dx is just x. And then you put in the limit. The upper limit is 900. So this being 900 minus 400 squared, which is here, 0.001 by 2, is written separate. And then when you put the lower limit of 400, the 400 minus 400 is 0. So I haven't written that. And then here it's just 0.5 is the constant, and the x would be 1200 for the upper minus 900 for the lower. And this all simplifies to 275. That was e of y. Next we need e of y squared. So the same thing. Now we integrate y squared against fx. Again, the same thing between 400 to 900. Y was x minus 400. So it'll be x minus 400 squared. F of x is 0.001. And between 900 and 1200, y was 500. And so y squared will be 500 squared. So here again, you pull out the 0.001 and the integral of x minus 400 squared is x minus 400 cubed by 3. And here all this multiplies to 250. So the integral would be 250x. And then here you put in the upper limit, that's 900. And the lower limit is 0. And here it's just 250 times upper minus lower. And all this simplifies to 116667. Now, when the numbers involved are of this magnitude, you don't have to worry about the decimal places. And you can very comfortably round it to an integer. Variance of y, be e of y squared minus ey whole squared. So e of y squared is this. And e of y was found to be 275. And this simplifies to 41042. That was choice C.